Right, hello all. I've had a request to go over question 3 from Hess's law, combustion. There's a couple of ways in which to do this. The question that we are doing is question 3 of fermentation of glucose. So, two ways in which you can do Hess's cycles. The first one is by doing a cycle. I'm going to do both methods and then you can choose which you prefer. Right, so we're going to start off with glucose. We're going to form 2 lots of ethanol, and it's also going to release carbon dioxide gas. And what we're being asked to calculate is the enthalpy change of this reaction here. Now, we are given delta H of combustion information, which means that the common oxides are produced and energy is released. So from this we will produce 6 lots carbon dioxide, 6 lots of H2O. And in this case both the arrows go in this direction, and we'll call this delta H1, change in energy for this combustion reaction, and this one we'll call delta H2, enthalpy change of this reaction. Excuse me. The calculation that we're trying to work out is this one. Unfortunately, for whatever reason, we can't directly calculate it, so what we have to do is go by an alternative route, which is what Hess's law is all about. So what we do is we construct an equation like this one, where delta HR is equal to the enthalpy change for reaction 1. Now we're going with the arrow, so it's going to be plus delta H1, and then we continue the arrow around, the root round, and then we go against the arrow, so we do negative delta H2. Now we're told from the paper that excuse me, that the enthalpy of combustion for glucose is minus 2820 kilojoules per mole, and the combustion of ethanol is minus 1368 kilojoules. However, we have got 2 of them. So we can substitute these values in, and we say that delta HR for this reaction of fermentation is equal to positive minus 2820, take away 2 lots of minus 1368. Now, common mistakes are to get confused with these positives and negatives positives. It gets a bit of a mess, but just be really diligent when doing these, and it should work out. So I'm going to pop it into the calculator. Minus 2800, take away 2 times by minus 1368, and we get minus, oh sorry, I made an error, minus 2820, read that as a 0, take away 2 times minus 1368 equals minus 84 kilojoules per mole. Now, that is the cycle method. Most people don't tend to use this one. They tend to use this one, which is that the enthalpy change for any chemical reaction is equal to the sum of the enthalpies of combustion for the reactants minus the sum of all of the enthalpies of combustion for the products. Now, we'll go back to this. We know these are the reactants and these are the products. So all we do is we substitute the values in, and again, be careful with your signs. So this is a positive, so this is the enthalpy of combustion for the reactants, which is glucose, which is still minus 2820. We're going to take away the sum of the combustion of the products, which is for this one, and we've got 2 of them. So it will be minus 1368. Tap that in the calculator and you come out with 84 kilojoules per mole. Again, either method is fine. This one tends to be the preferred one because it's quicker. But you just need to be really careful with number of moles and all of the signs. I hope this helped. If you'd like any others done, perhaps you would like to leave a comment in the section below. All right, thank you. Hope everyone is well. Take care. Bye.